Welcome to Real Civil YouTube channel. In this video, I am going to discuss with you uh, the topic pushover analysis. I have made couple of videos on how to perform exactly the pushover analysis in ETABS software as well as in SAP 2000 software. But many students are facing understanding the concept of the pushover analysis. That's why I have made this video in which I'm going to explain you what things are there in pushover analysis. So let's get started. So first we'll see what is pushover analysis or what is the concept of pushover analysis. So first you can see here I have a 3D model of the building which is non-linear multi-degree of freedom model which consists of geometric non-linearity, material non-linearity, uh, and this building is subjected to the ground shaking. Okay, so this is what generally the practical case: a structure, a building subjected to earthquake. Okay, some ground motion, some ground shaking in either x or y direction. Okay, so this is the practical case. Now we can assume or we can approximately represent the same condition as a multi-degree of freedom model. So here you can see this is the model subjected to lateral load. So these are the lateral load. So this is the lateral load pattern. So pattern means this is in a triangular shape. The load pattern is in triangular shape. So we can approximate this scenario as a multi-degree of freedom model subjected to lateral load pattern, a set of forces acting at each story. Okay, so a set of forces is acting at each story and the magnitude of these forces are increased monotonically while maintaining their shape. Okay, so load pattern shape will be same, only the magnitude will be increased monotonically. Okay, that means, for example, in this pattern, suppose here we apply, I'm giving just example 1 kilonewton in first step, then I will increase it to 2 kilonewton, 3 kilonewton, 4 kilonewton. That means step by step I will increase the magnitude of the force. Okay, so what is the basic difference between these? So here there is actual ground shaking, and in this case there is lateral load pattern. Okay, so there could be different loading patterns. Okay, so pattern remains the same, but the magnitude of the force goes on increasing. That is, some factor is applied. So starting from like very low value to the very high value, and these forces are applied step by step. So very important word is here, a step. Okay, so for example, in first step some magnitude is applied, in second step the magnitude will be increased, okay, monotonically. Now these forces are applied step by step. Okay, and when we apply the force, we record the displacement of a particular node which is at the roof level. Generally a node from the roof level will be considered, and because of application of this lateral load, the displacement of this node is monitored. That node is called as controller node. Okay, so As a product, what we are getting? We are getting the push over curve. Okay, so on y-axis there is a base shear, on x-axis there is a roof displacement. Okay, so as I told you, generally a roof from the a node from the roof level is considered, we will monitor the displacement of that particular node under monotonically increased load. Okay, so whatever curve you are getting, that curve is called as pushover curve. So simply it is base shear versus roof displacement. So basically pushover gives us force versus deformation curve. So each point here, each point on this curve represent one static analysis procedure. As our model is considering the non-linearity, it also consider the non-linear behavior. Okay, so generally this is the output from the pushover analysis, that is the pushover curve. So it is important that every point represent one static analysis, means we have applied some load, then we will see what is the displacement of that node, then the magnitude of the force increased, then what is the displacement. So likewise we are increasing the load and will see the displacement, and then we will plot a graph or curve which we call the pushover curve. Okay, now what output we get from the pushover curve? Here another pushover curve I have shown here. The first thing that we are getting performance of the building, means what? From no loading till the collapse we are applying the load and we are monitoring the displacement. So entire performance of the building is with us. Second, base shear developed, or what is the maximum base shear developed. So if you see the graph, so here we can see, so that much maximum base shear can be developed in our structure. So if a future earthquake generates a base shear more than this, then the structure is not going to sustain. Third very important thing, yield point of the building. As you can see, as initially as there is very less load and then we are going to increase the load, first part is straight and then it is getting into non-linear behavior. So we can identify that yield point when our structure is starts to yield, when our structure is going into a non-linear behavior. That also can be determined from this. Okay, the next, weaknesses in structure. So as you can see in this pushover curve, the pushover curve goes like this and then suddenly drops. So you can see this, there is a sudden drop in the pushover curve. So that means the behavior is not a ductile behavior, it is a brittle failure. I have another pushover curve from one research paper which I have cited here. So you can see the it goes linear and suddenly it gets flat. That means any particular element is getting fail. Okay, like a sudden failure, or it is maybe example of progressive collapse also. Okay, so this much of uh, data can be studied from the pushover curve, like performance of the building, maximum base shear, yield point of the building, and suppose there are some weaknesses in the structure can be identified using this pushover curve. But if you see, this pushover curve alone is not a useful thing. Why? I will tell you. Here, we need to determine the seismic demand. Okay, and to determine what we want to determine, seismic demand. To determine the seismic demand alone, this curve is not useful because we don't know much how much roof displacement will be there in future earthquake. For example, our structure is situated in a particular area, and we don't know future earthquake is going to displace our structure how much. Okay, this is just a journey of a building from no loading till say collapse. Okay, but somehow if we calculate the displacement of a structure that may occur in future earthquake, then it is a very useful thing. So for example, if I done the calculation and I come to know that in future earthquake my structure is going to have this much of roof displacement, then I can see how much base shear can be generated, how much shear force, how much bending moments are there in the members of the structure. That can be found if I know that displacement. Okay, so that's why it is very important to find the performance point of the or performance point. That means how much displacement will be there in future earthquake. If you able to find that point, then we can think like how many hinges are forming, then hinges are in which level, what are the magnitudes of the shear force, bending moments, so that can be studied and accordingly our structure can be designed or retrofitted. Okay, I hope the concept of pushover analysis is clear. If you have any doubt, you can ask me, I will reply, or you can see our other videos related to the pushover in ETAB and SAP. Those links are available in the description box. Thank you. Thank you so much.